Hello students, welcome to my channel Project Talk. Today's topic is a Coulombs Law. In my last video, I have discussed with you all about the charge. What is the charge? What are their properties? What are the method of charging? And today's topic is a Coulombs Law. Dear students, beginning this journey, I would like to tell you that there is a big confusion in our mind that we are going to derive it or we are going to prove it mathematically. Dear students, in throughout the physics, there are the two laws which are most natural, which are said to be the most natural law. Most natural law means there's no mathematical derivation at all. These laws are the result of experience of generations. You cannot say that Coulomb's law is the result of Coulomb's work only. Or you cannot say that Newton's law of gravitation is the result of Newton's only. Even before the Newtons, so many people were known to the fact that Earth is attracting everybody towards its center, right? Newton's law of gravitation and Coulomb's law are supposed to be the most natural law. So, today's topic is a Coulomb's law, right? Dear students, in my last video, I have discussed with you all that about the charge, that after the evolution of the man on this green planet, he came to know about the charge because the thundering in the sky, lightning in the sky, that all must enhanced his curiosity to know about all that. So human being was known to about the charge even the 1,000-2,000 years before. But what Coulomb's law tells, what Newton's law of gravitation tells, that how these knowledge of human being can be used for the welfare of humanity. Dear students, today's topic is a Coulomb's law. What Coulomb's law says, that the two charges, let there are the two charges Q1 and Q2 which are at smaller distance apart. Then according to Coulomb's law, the electric force acting between the two charges is directly proportional to the product of their charges and inversely proportional to the square of the distance between the two charges. You can say that F is proportional to the Q1, Q2, directly proportional to the product of charges, and F is inversely proportional to the square of distance between the two charges. If you match these two equations, you will get F is proportional to Q1, Q2 upon R square. And now, in order to just remove the proportionality, you have to multiply a constant K, that is Q1, Q2 upon R square. And here in this case, K is equal to 1 upon 4 pi epsilon naught. So our equation becomes F equal to 1 upon 4 pi epsilon naught Q1, Q2 upon R square. Now, dear students, the value of 1 upon 4 pi epsilon naught works out to be 9 into 10 raised to the power 9. Right? So this equation is true for the free space. This is true when the charges are kept. When the charges are kept in free space or in vacuum, you can say that F is equal to dI students. What I have done, that for the electric force acting between the two charges is directly proportional to the product of charges and inversely proportional to the square of distance between the two charges. From these two equations, you may write F is proportional to Q1, Q2 upon R square. F, in order to remove the proportionality, I have multiplied with a constant K, and K works out to be 1 upon 4 pi epsilon naught 9 into 10 power 9. Dear students, between the masses we consider the gravitational force, and between the charges we consider the electric force. Electric forces are one of the strongest forces considered in the universe, right? Now, dear students, in the Newton's law of gravitation, force is only attractive, whereas in the electric forces, Coulomb forces, might be attractive, might be repulsive, depending on the charges. If the charges are odd in nature, I mean to say that one is a negative and there is a positive, then the forces will be attractive. And if the charges are even in nature, I mean either both the charges are positive or both the charges are negative, then the result will be, the force will be repulsive. Now, very interesting to know that this law we have derived when the charges are kept in vacuum. So, force acting between them works out to be F equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. It is inversely proportional to the square of distance between the two charges. It means if the charges are far away, the force would be little, and as soon as the charges comes closer to each other, the force will be stronger. If the charges are away, charges are far away, charges are distance apart, then the force will be weaker, and if the charges are closer, then the force will be stronger. Now, dear students, we have talked, the equation is, let's again discuss. The equation we have got, F equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. This 1 upon 4 pi epsilon naught is a constant and its value is 9 to 10 raised to the power 9 in MKS. Always remember the unit that is in MKS. Now, dear student, what is epsilon naught? Epsilon naught is permittivity of free space. Permittivity of free space. And its value works out to be 8.85 into 10 raised to power minus 12. And epsilon naught being here, so unit will be Coulomb square over Newton into meter square. Dear students, sometimes there is no need to mug up or to learn the units. Units you might derive just what I have done. I just missed the unit. So epsilon naught if comes here, 4 pi is a constant, is a dimensionless, do not possess any unit. If I brought here, so it's a Coulomb square or per Newton into meter square. You also can, sometimes when I was making the videos on the dimensions, I have just talked about the 3, 4, 5 dimensions, and I have told that as soon as you will move further, you will be acquainted with the new quantities, you will be familiar with the new quantities. At the very moment you should find the dimension, right? So let's find the dimension. Epsilon naught will be what? Now look here, epsilon naught I have brought here. It is, you have to find the dimension Q1 Q2 upon F into R square. Very simple. F is a what? MLT minus 2. R square is a L square. I hope you would be seeing, you would be watching. Yeah, this is appearing, no problem. I was thinking that just a camera is high. So F into R square, F is a MLT minus 2, R square is a L square, and Q is what? Current is what? Charge is not a fundamental quantity. Current is a fundamental quantity. So I is equal to Q upon T. Rate of flow of charge is called current. So Q is equal to IT. So A into T. So every charge has a dimension AT. So this is AT, this is AT. So it becomes A square T square. So you will get M L. Now it M you will bring it numerator becomes M minus 1. This is LQ. When you will bring it to numerator, it turns L minus 3. Now T minus 2, bring to numerator T square, T square, T square, T raised to the power 4, and then A square. Now dear students, we find the dimensions of epsilon naught. Find the force acting between the two charges. F is equal to 1 upon 4 pi epsilon naught Q1 Q2 over R square. 1 upon 4 pi epsilon naught is a constant, and In n cases, the value works out to be 9 into 10 raised to the power 9. Epsilon naught is called to be the permittivity of the free space. Now, dear students, very important. The one quantity I have to discuss with you all. Dear student, this formula you derived when the charges were kept in the vacuum. Let the charges are kept in a medium. Let the charges are kept in a medium having dielectric constant capital K, then F is equal to 1 upon 4 pi epsilon naught K Q1 Q2 upon R square. Dear students, I like to tell you all that dielectric constant is a term that is used when you will be studying the capacitor. When I make videos on capacitor, I will discuss about the dielectric constant, what it is. Now, if the charges are, but you can say that for the vacuum, for the vacuum K is equal to 1, and for water value of K is maximum, that works out to be 80, right? Again, I am bringing back you on the topic. Let it is F naught. When the charges are kept in vacuum, let the force acting between them is a F naught, and F naught is equal to 1 upon 4 pi epsilon naught Q1 Q2 over R square. If the charges are kept in a medium, kept in a water, kept in a oil, kept in any other medium, right? Then force becomes 1 upon 4 pi epsilon naught K Q1 Q2 over R square. For the vacuum, K is equal to 1. For the water dielectric constant is a maximum, that works out to be 180. Now look here, dear students, 1 upon 4 pi epsilon naught Q1 Q2 upon R square is a F naught. F naught is the force acting between the two charges when they are kept in the vacuum. And when you kept in the medium, the force acting becomes 1 by K of the force that is acting in the vacuum. When the charges are kept in the medium at the same distance as they were kept in the vacuum, then the force acting between the charges becomes 1 by K times of force acting between them when they are kept in vacuum. Now, because K is greater than 1 for all the medium, either it is K equal to 1 for the vacuum, or for other medium, K is greater than 1. So, if K is greater than 1, so you can say that F is less than F naught, right? F is less than F naught. Means, if the charges are kept in a medium rather than vacuum, then the force will be decreased by 1 upon K, where K is a dielectric constant. Let's move further. Dear students, next topic is a Coulombs law in vector form. How will you find that? We have to define the Coulombs law in vector form. Dear students, very important thing to tell you, I am discussing with you a very important factor. If you want to be familiar with the good physics, if you want to attain a good knowledge of physics, you think that you should know the concepts about, then there are the 3 tools you have to be. I'm not saying that you should be master of that tools, but you should be familiar at least with these tools. First one is what? That is a graph. You should have an idea of the graph, that this equation represents, a particular equation represents what kind of graph. Either that is a circle or ellipse or a hyperbole or a straight line or whatever, but you should know what does it represent, how the graph of log is drawn, how the graph of exponents are done, what is the how mod is, how the mod x you can plot, how the mod x minus 1 you can plot. I'm sure and I promise you all, just within 2 or 3 days, you will get my videos on the graphs. Second one, vector. These are the tools used to understand the concepts of physics. First one you should know about the graph, and second one is the very important tool that is called vector, and third one is first is a graph, second is a vector, and third one is a what? Calculus. Calculus means differential and integral. Dear students, you should have a basic knowledge of these three tools: graph, vector, and calculus. One by one I will discuss with you all in my next videos, not today at all. So, because it comes to the vector form of Coulombs law, that's why I just shared my views with you all. That let's discuss the Coulombs law in vector form, right? These are the two charges, Q1 and Q2. Distance between them is R. Let position vector of Q1 is R1, vector R1. Position vector means, position vector is a vector which locate a point with respect to a reference point. Reference point is here origin. Means with respect to origin, it's a distance and angle that is making from the x-axis. Or that is a position vector. Position vector, as you said, that if you just consider our coordinate axis, so right, it is x, it is y, this is origin, it is a point P which has a position vector, vector r. You can say this angle is a theta, so it is a coordinate. You write like x, y, z, you can write r theta, this is said to be the polar coordinate. But I have not to go into deep at all. That you can say that position vector is a position of a point with respect to a reference point. Reference point might be your origin. Now Q2 has the position vector, vector R2, right? This is. Dear students, we have written this way, and now let both are the positively charged. Then Q1 will repel the Q2, and the force acting will be along the line joining the how the force act between the two charges. The direction of the force acting between the two charges is along the line joining them. Now, dear students, this Q1 is repelling this Q2 in this way. So it is, I am writing is F21, force acting on second due to first in this direction. And now look here, this charge will repel this one in this way, and this becomes F12, force acting on first due to second, right? Force acting on first due to second. Now, let's solve. You say that the force acting between, according to Coulombs law, force acting between the two charges 1 upon 4 pi epsilon naught Q1 Q2 upon R square. I'm not discussing it all, that whether it is kept in a medium or in vacuum. Let it is in vacuum. F is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. This is the magnitude of the force acting between the two charges which are small r distance apart. Now, dear students, let's find out F12. It's your choice whether you want to find out F21 or F12. Let's find out F12. When you say F12, that is means you are talking about the force acting between the two charges in vector form. F12 means force acting on first due to second. That is equal to, let a vector is vector A. You can separately write its magnitude and direction both. So it is a magnitude becomes mod of vector and its direction becomes NA cap. NA cap is a magnitude of, is a unit vector that tells you only the direction. So it is a magnitude and direction we have written separately. Now dear students, F12 is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon, now the distance between 1 and 2, R is a what? That's the vector R12 mod, right? R is a what? That is the distance between Q1 and Q2, right? This also can be written as R21, sorry. Why I am writing this, you will know. Just let from 2 to 1, this vector is a vector R21. So mod of R21 is a mod of vector is a this line, length of this line, that is a R, and it was R square, so it is R square. Now you are writing F12, means direction is like this. Here I am writing, this is a magnitude of the force only, right? There is no any vector quantity. Here I have written R21 vector, but it is a mod, means R21, you are concerned with the magnitude of the distance between Q1 and Q2, right? Here you have written mod of vector R21, right? And now this is F12 is the direction like this. So I am representing this direction by R21 cat from 2 to 1. It is a unit vector representing the direction from charge Q2 to Q1, right, towards Q1. Now you have written this. Now you know n cat becomes vector A upon mod of vector A. So you can write like this, F12 that is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R21 square, and now R21 cap is equal to vector R21 upon mod of vector R21. Now dear students, look here, you can write this vector plus this vector is equal to this vector, like this is vector R2 and this is vector R2, right? I have written this, and from Q to Q1 it is let vector R21, right? And this one is a vector R1. So applying the vector law of addition, you can say in this vector this has been added and resultant is this. The direction of resultant is always from initial to final point. So it becomes vector R2 plus vector R21, that is equal to vector R1, right? So R21 vector is equal to R1 vector minus R2 vector, right? So our equation becomes, look here, our equation becomes F12 is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon this, these two are the same quantities, so it will be vector mod of vector R21 cube, and now it becomes here, it is a vector R21, you might write like this R1 minus R2. In similar way, you can find out the value of F21. F21 means force acting on charge Q2. So F21 is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon it will become, I'm sure, R12 mod of R12 cube, and this will become R2 minus R1. And dear students, if you will compare these two, you know, you will find that vector F12 is equal to minus vector F21, or F12 plus vector F21 is equal to 0, right? This is, you can say, it is result of mutual force acting between the two charges. You can say that the important result you have to discuss here, mod of F12, that is equal to mod of F21. This is important. Means the force acting on 1 due to Q2, the force acting on Q1 due to Q2 is the same whatever is the force acting on Q2 due to Q1. These are the mutual forces. If the F is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square, the charge acting between the force acting between the two charges, you have got 2 Newton. It means on both the charges 2 Newton force is acting due to each other, right? This is the result of Newton's law of action and reaction. That is why their sum becomes 0, and you can say that it is just internal force arising due to internal property. Now this is, so mod of F12 is equal to mod of F21. This was the vector form of, first I discussed with you all the Coulombs law, then I discussed with you all the Coulombs law in vector form, and now dear students, very important topic I am going to discuss with you all. That is a principle of superposition. In as a matter of minute, we will discuss with each other. Principle of superposition. This one, let a charge is Q0, right? And here it is a Q1 charge. It is the origin. It is Q2 charge. Have the position vector R2. Q1 has R1. Q3 has R3. So on. So many charges are around the charge Q0, right? There are many charges. Q0 is a positive test charge. When we discuss about the Coulombs law or electric field, just we will discuss a moment after, we talk about positive test charge. It is also a similar charge, has a unit, it is a least positive charge, right? We are discussing when we say positive test charge, why do we consider only positive test charge? We might consider negative test charge, but it has been recognized internationally to define the direction of electric field. That is why everyone has to consider positive test charge. Just my name is Ranjan and my dad said that is a lovely name, so I called Ranjan, and even today I am. The same concept there. Now dear students, there is a positive charge Q0 and so many charges Q1, Q2, Q3 having the position vectors R1, R2, R3 are around it. Now we have to find out the force acting on test charge, right? The principle of superposition is that the force acting on a particular charge is the vector sum of the forces acting on that charge due to other charges. The force acting on a particular charge is the vector sum of all the forces acting due to other charges on that particular charge. It is saying that if you have to find out the force acting on Q0, then find the force due to Q1, find the force due to Q2, due to Q3, all the force acting on all these charges on Q0, and then take the vector sum. It means what we have to do, vector F0, force acting on Q0, that is equal to, or vector F, that is equal to F01 due to first one, F02 due to second one, F03 due to third one, dot dot dot. F01 was what? 1 upon 4 pi epsilon naught Q1 Q0 upon this is R01 square and then R01 cap, right? F is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square, right? Q1 Q2 upon R square R cap. Just you have find out, right? The second one becomes 1 upon 4 pi epsilon naught Q2 Q0 upon R02 square. don't write vector here, right? R naught 2 square, that is distance between Q naught and Q2, and the direction I'm writing R naught 2 cap, right? Plus so on. So you can take Q naught upon 4 pi epsilon naught, take out. So it will become Q1 upon R naught 1 square R naught 1 cap plus Q2 upon R naught 2 square R naught 2 cap plus dot 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 like so on. Okay? But the main concept is that you have to understand, let the three charges are Q1, Q2, Q3. First the two charges are kept Q1, Q2, and the force acting between them is 1 Newton. Let you brought another charge and you place another charge Q3 here, right? Now principle of superposition says that the charges acting individually between Q1 and Q2 will remain unaffected by the presence of any other charge. Means when the two charges Q1, Q2 were kept, the force acting was 1 Newton. As soon as you brought another charge Q3, even then, in the presence of Q3, the force acting between Q1 and Q2 will be invariant, will be unaffected by the presence of Q3. Means the force acting between Q1 and Q2 will again be 1 Newton, right? Yet the resultant force on Q1 or on Q2 will change because the Q3 has come. If you want to find out the force Q on the net force, the resultant force on the Q2, you have to find out the force due to Q1. On Q2, you have to find out the force on Q2 due to Q3, and then what you have to do, you have to find out the vector sum of these two forces, and then you will get the resultant force on Q2. But again I'm saying, the force acting between Q1 and Q2, either in presence of Q3 or in absence of Q3, remains constant. It will be same as it was before the presence of Q3. Now this was the principle of superposition. Dear students, I tried my best to make you familiar with the particular article that was going on here. I hope you will be following. If there is a problem regarding to this video, there might be the questions in your mind, do ask to me. I will try my best to let you understand. If you think that my videos are beneficial to you, then please and please like, share and subscribe, and do comment, and must put the bell icon so that you can be notified about my new videos. Thank you. Meet you in the next video very soon.